Welcome everybody. Hold on. Welcome everybody to another episode of vBrownBag. Today we have a very special guest, Bhavin Shah. He's gonna talk to us about AppDefense, which is a new product that was just released in VMworld. And we're actually gonna get a deep dive session, so this is pretty cool. So some quick notes that we always do. You get in the conversation, get on Twitter, hashtag us. We have the EMEA, the LATAM, the US show. You can see the schedules. You can go in and sign up. And with further ado, I'm going to pass over control to Bhavin. Bhavin, make sure you introduce yourself, and I'll leave the floor to you.
Thank you, Ariel. So today I'm going to talk about App Defense. One of the spotlight at VMworld 2017 was focused around App Defense. My name is Bhavin Shah. Been with VMware for almost 2.5 years, based out in Princeton, New Jersey, and I'm part of App Defense Field team. So in order to start what App Defense is, what I want to start doing is start trying to understand what problem are we trying to chase, right? So the first goal of App Defense is to understand what problem we are trying to solve. So we all know that VMware is not known as a security vendor or a security company. So it can be at our biggest advantage because based on what you're seeing in the security theater, even though customers are running antivirus, anti-malware, there are zero-day attacks that are causing Equifax to melt down. That are causing those WannaCries to basically encrypt everything in the environment. So with the current architecture we have in the world of security is not good enough the way the attacks are happening. So the focus here is that where is the existing problem in the current security strategy? So if you look at the way security is done mostly today is two ways, right? So the first one is based on signature. So there's an attack which happened at Equifax for Apache threats, and based on that pattern, you basically create a signature and you try to focus on that known bad behavior and update your threat database for the signatures for your antivirus, IPS, and so on. The main challenge with the signature-based approach is that the focus is very, very narrow, and it's always after the fact. So it's going to almost miss every zero-day attacks, and that's where we see a lot of records and a lot of data centers getting compromised. The second approach, which we often use in the world of security, is based on analytics and behavior analysis. So based on the advance in technology with machine learning and artificial intelligence, the main aspect here is to look at the analytics and behavior of a particular system and then focused on the unknown bad behavior. The issue with behavioral or analytics-based system is the focus is going to be very, very wide because you're basically collecting logs from all the systems or tapping into your SIM systems, your analytics, and so on. So the focus area is pretty wide, which results into very high false positive that I think the security operators are very, very familiar with. So at the end of the day, the challenge in the security theater based on the approaches, which are either based on signature or based on analytics and behavioral analysis using machine learning, has got their own challenges. So when I look at the data center today, right, I see based on those two approaches, some green and some red, but there's a lot of blue and a lot of gray when you look at the data center today using those approaches. And the main issue here is that the systems are highly complex and you don't get better signal to noise ratios. You're always chasing the threat. And since there's a lot of high rate of false positive, you cannot remediate the action in an automated fashion. So once you detect some kind of anomaly, the effort to stop that threat is always going to be manual. So that is what we are trying to focus on, right? Given that we are new to the world of security, we are trying to change the way the security is architected so that we can focus more on the zero-day attacks. And at the same time, rather than chasing the bad behavior, I can ensure what is a known good state of an application. So I'm exactly trying to take the reverse approach in the world of security. So rather than chasing bad, if we can ensure what is a good known behavior of an application, we can narrow the focus on our application and protect those endpoints today much better. And again, the one thing in the world of security, what I've seen in my past 20 years is the security war is very, very asynchronous. We as security operators have to protect thousands of endpoints and have to be successful all the time. Whereas an attacker has 1,000 times to attempt to attack a data center, and they need to be only successful one time. So again, changing the approach by ensuring what is good and protecting it versus chasing bad, we seriously think is going to change the security theater and keeps the attacker at the bay. So what does app defense means in total, right? So folks who are familiar with NSX, the approach was NSX was to create or align the security controls in the network closer to the application by creating a least privilege model for the networking layer. Taking the concept furthermore, the focus here is that creating security controls in the compute layer that can be aligned to application by which we can create a least privilege model for a compute layer, then we can basically achieve the focus point of keeping the threats out of the data center and creating a library of automated and orchestrated response whenever we do a threat detection. So again, just to reiterate, the mantra behind app defense is to focus on ensuring good rather than chasing bad. And one thing I always remember is that if you look at the database today of good known threats out there, there are around 27 million entries in the global threat database that all your antivirus, anti-malware vendors are protecting data centers again. But still we see the attacks happen at Equifax, Sony, Target, what may have you. So what we have documented based on app defense running in our customer environment in the early field trial, we have 91 good behaviors that we have documented based on what you can ensure and protect your application. So end of the day, the goal here is I want to shrink and simplify the problem of security by putting a laser focus attention on what the workload is supposed to be doing, so that if there's any deviation on that intended behavior, I can now get more focus and try to narrow down the exploit that is trying to attack my workload. The main goal here is it's a standalone SKU that comes with VMware. The pricing is done per socket on a yearly based subscription. It is a SaaS model available in 1, 2, and 3-year prepaid option. And if you look at the overall theme of app defenses, what NSX microsegment did to network in creating the least privilege model for network, we are trying to do the same thing with app defenses to create a least privilege model of compute. So now we can align the security controls in the field of networking and compute closer to the application. And end of the day, the goal is to automate and orchestrate the response when there's any kind of threat happening in the data center environment. Based on interaction with customer over the last 4.5 weeks, few of the use cases that I come across based on talking to customer and talking to the early field trials who have been deploying this solution in their dev test and production environment, the major use case of app defense in the world of application control. So it basically is the endpoint detection and response system. So you can create a data center application endpoint security using the application control. The second most solution which is needed in the marketplace of security theater is around automation process for the remediation when a threat happens. So given that app defense is focusing on a good behavior of an application, we are going to reduce huge amount of false positive that you see in your SOC data centers today, right? So once we can reduce that amount of false positive, we can, with concise and precision, remediate the response process in an automated and orchestration fashion. So what we have done is we have created a set of libraries with ESX, NSX, and our third-party ecosystem vendors like your SIM tools, Splunk, RSA, or Carbon Black for your AV and so on, that you can basically bring in and integrate with App Defense to create a library of automated and orchestrated response whenever a threat is detected in the data center. The second most important use case, what you're saying based on customer interaction, is that now AppDefense provides you a single source of truth that your application developers and your security practitioners can tap into. Because oftentimes happens that the application guys know everything about their processes and what's the end goal for the process is, and the security guys knows everything about what ports, protocols, IP address that the process is trying to access to. But application guys do not know anything about ports and protocols and headers, and security guys don't know anything about the processes and the application. So given this is a single source of truth, they can both tap into this database and understand what process is trying to create what ports and protocols for inbound and outbound communication, and what resources that process is trying to access. And the application developer can understand what ports and protocols they are trying to open. So now this becomes a common source of truth that can be used as a collaboration tool. And one of the highlights for me, especially at VMworld 2017, was we showed a companion app, which is an iPhone and an Android app that can be used by your application developer and security practitioners, that they see any behavior change, they can basically create a ticket and send it out to the application developer, and they can start responding in real time. So that allows us for a lot of collaboration between the security professionals and application developers in a real-time environment, in a real-time fashion. And there's something that we use internally in our own VMware IT as well, because we had the same problem that we faced with our application team and the security team. So this is the tool that can bring that process and people together as well, along with technology, to allow you for that application control. And the third thing we always talk about, when you talk to a CISO, right, they have basically created another group within CISO. They call it CICO, which is the Chief Information Compliance Officer. And the whole day job of that compliance officer is to make sure that anything and everything that is running in the data center is basically compliant to the standards that they need to adhere to. And at the same time, whenever an application gets rolled out in a production environment, it has to go through a security readiness review. So what we have found with our customers is they're using this AppDefense single source of truth to automate the creation of that application readiness review when they roll out the application in production. Generally, that process is somewhere between 30 to 90 days and requires application team and the security team to be collaborated and communicated. And this process of creating a secure database for everything that an application is supposed to do, which you call it a single source of truth, allows for that readiness review of an application to be completely automated. And again, the second thing is we know as VMware that we are not going to be a primary glass for the SOC operators. So what we're also trying to do here is that all the information that we have from the application centric, we are actually feeding into the same tools like RSS Splunk. We are feeding that information into our third-party ecosystem security vendors. So now they can ingest that information and reduce the amount of false positive that they show on their screen. And again, the remediation can be done through that primary glass, and we'll create and constitute those constructs in the backend to make sure that the remediation happens. So again, the goal here is that everything that we learn as a part of AppDefense will basically ingest it as an application birth certificate into the same tools. And I often ask this question, like, how does this product either replace or complement what I'm running today in my security theater, right? So this is something that came out from Gartner as of March of 2017. And I've been doing security for almost 15 years. And the two buzzwords in the world of security is always a layered approach, or they also call it defense in depth. So if you look at this Gartner triangle, right, I basically look two compartments here. One is called the core workload protection strategies. Those are the foundational elements for security. And then you will always have the additional workload protection strategies that are running on top of the foundational pieces in security. So if you look at the core protection strategies that one has to deploy in order to make that foundation secure, comes in way of hardening your existing vSphere environment, which I think we do a pretty good job at VMware. The second pyramid step is basically the network firewalling or the network segmentation. And we have solved that problem using NSX microsegmentation. At the same time, we have provided a lot of visibility due to NSX microsegmentation going across the network, as well as your compute construct. The core workload protection strategy also includes application control or whitelisting. And that is the problem that AppDefense is basically trying to solve for. So AppDefense fits into that application control that customers are looking into in order to create that strong foundation for security. And of course, you're going to run your antivirus, anti-malware, IPS, IDS system as a part of additional workloads protection strategies to allow you to have this entire security end-to-end or defense in depth approach. So this is the entire app defense in making. So what I'm trying to show here is what are the main techniques that we use as a part of app defense. So the three phases of app defense, or the three primary constructs for app defense, are basically capture, detect, and respond. So the way I want to start this is we spend almost 80 to 90% of engineering time in the capture part of app defense. Detection and response is something that we can do it very easy if we get the capture phase right. So in order to understand the capture phase, let me just give a little description on application. What is an application? Because coming from security and networking world, I often struggle to define application. So when I look at the application based on my learning in my customer environment and based on app defense, application has four compartments. The first one is it has got some kind of process running on it. Your Apache web server, or you got PowerShell CLI, or your Power CLI, or PowerShell, or what may have you, right? So that is a process that basically defines an application. Application also got operating system calls that the process makes in order to get access to the resources for the applications to perform. So those basically are the system or the kernel calls that the application makes in order to get those resources from the system. The third compartment of an application is it needs to make an outbound connection to either talk to your DNS server to get basically a IP to name service lookup. It also needs to talk to DSCP server to get an IP address and so on. So those are all the outbound connections that an application has to make during the life cycle. And then often if you're running a web service, then your connections are also coming from internet into that application. I call them inbound connection. So the application basically constructs of processes, system level calls, inbound connections, and outbound connections. And if you look at that application compartment, oftentimes what happens is, as an attacker, what an attacker does it either tries to enumerate a process, or it tries to create a new process to access the memory or so on, and that basically causes a lot of threats in the environment, right? So when in app defense, what we do here is we try to build an intended state engine of an application. So the first and the foremost things what we do here is, as a part of app defense, when it comes up, it basically taps into your vCenter. So we basically registers to your vCenter and do the crawling of your vCenter, which gives us all the information about your host and your virtual machine. One thing we do not get from tapping into vCenter is basically your process and your connections those processes are making. But you understand the lay of the land of all the hosts and the virtual machines that are running in vCenter. And these are the objects that our customers have populated by running vCenter for last 10 to 15 years, depending on where you are in the world of vCenter. The next thing we do is, if you have got any infrastructure provisioning system, like your Puppet manifest files or your chef recipes that you're using to instantiate your application, we basically go and tap into those manifest files to understand what this application is trying to do. Because once we know what this application is trying to do, we can basically ensure the good for that application. So what we do is we tap into your infrastructure provisioning system, which are your Puppet, Chef, VRA, in order to understand the scope of the particular application, what it's trying to do. And again, as you know, that applications are not going to be static. They get upgraded, they get migrated over the time to the next version and so on. So there's going to be a different state in the runtime than what was basically at the provision time. So what we do also here is we tap into the application automation frameworks, which are your Jenkins, Maven, SCCM, the tools that basically are responsible for upgrading your applications. And we basically understand the runtime behavior of that application based on the tools as a part of building the application scope for that particular system. And we do machine learning as a part of building up the application scope as well, in order to build the intended state engine for each application. So again, we crawl all the system in order to make sure that we create that state of an application which is solid. And we also tap into ESX to understand the manifest files of those VMs that we can store in to basically compare if there's any kind of deviation. So intended state engine is basically the crux of AppDefense in making. This is where we create the intended state of an application. So once we have that intended state of an application, if there's any deviation from that intended state, we can basically detect that state and do fancy things with it. So that gets me to the detection phase. We at VMware from day one have taken a stand that anything that we do in the world of security has to be embedded within the kernel or the hypervisor of the system. Because being in the world of security, if anything is deployed as an agent, the attacker, the first step they take when they come into a system is to go and stop the agent that is running on the system, right? We all know that pretty well. AppDefense is a system where we actually have an agent for your virtual machine. And what you've done with AppDefense is we have basically created a protected zone within the hypervisor, right? And we have the VM monitoring that is running in the hypervisor that monitors that protected zone where we create the manifest for the virtual machine with the manifest that the virtual machine has in the guest agent. So what we are doing here is that we are providing a shield to that guest agent that is running in the virtual machine in user space by checking it against the VM manifest that we stored for that particular agent in the protected zone of an hypervisor. So if there's any kind of deviation between the guest agent and what we know about that agent in the hypervisor, we can detect it in real time and take actions on it. So that is one of the key things we bring to the table here is that even though our AppDefense approach is an agent-based, we can provide a shield to an hypervisor, and we do provide shield to the guest agent by creating that secure enclave in the hypervisor and creating a monitoring station which can monitor the agent and compare it against the manifest that is stored in the hypervisor to make sure that if there's any kind of deviation, we can detect it in real time. And the response is always a big thing in the world of security. If we look at Target, Sony, Home Depot, and others, the systems will flag a lot of alerts when there's any kind of deviation, right? Your antivirus, anti-malware, what may have you. But given there's a lot of false positive today in the world of security theater, the reaction is always manual. And by the time we react, the attacker has already taken the data out and put it somewhere on the dark web where it gets sold for a pricey amount, right? So what we have done here is that, and we have focused heavily because our mantra from day one is software-defined data center. And software-defined data center basic premise is everything is software. So if everything is running in software, the key advantage of doing things in software is that you can automate and orchestrate your actions. So what we have done with AppDefense from day one is we have created a set of library for incident response when we detect some kind of a threat, right? And those libraries of response are basically based on ESX, NSX, and with our third-party ecosystems that comes to play in order to create those library routines. So just to define, right, if you detect a threat and you want to take an action based on ESX set of libraries that we have today, you can snapshot a VM, you can block a VM, you can suspend a virtual machine, you can set an alarm to your SOC operator on a SIEM tool saying something is going wrong here. With your NSX, what you can do is you can quarantine a machine, which basically means that when I detect a threat on an application, AppDefense is going to automate the process of tagging that machine with a tag called AppD, and then it calls APIs in NSX to create a security group and a security policy for a virtual machine that has got a tag called AppD. And the policy is very simple. Any machine that has got a tag called AppD, block all inbound and outbound connection. So the quarantine is the only action which requires NSX, right? As I mentioned, AppDefense is a standalone product. So only thing you require here is ESX and vCenter. If you want to do the automation of remediation and action is quarantine, NSX comes into play that can do quarantine for you. And as I mentioned, our goal is to integrate with third-party ecosystem in the world of security and provide their library of routines as a part of automation, in which case you can actually do a service insertion or a deep packet inspection when you detect that you're finding an anomaly in the behavior of a particular application. So this is basically the app defense in making again, right? So the three components, if you see the world today from the world of SDDC or cloud or your own private cloud or private data center, everything has got its common technology called virtualization, right? And the three aspects of virtualization that I'm going to focus on in order to build the intended state of an application is application, right? Because it's all about application now. Our VP Millen has said that application is a new network, right? So what we do, because we are sitting in the hypervisor, we see each and every call that is coming out of your virtual machine or your application is trying to make in order to access the resources from the compute layer, from the network layer, and from the storage layer. So we have that application visibility in that virtualization fabric that we are trying to leverage. Because once I have that visibility, I can leverage that visibility and capture it to create that state of an application. And I'm capturing it at both time. I'm capturing when the application boots up, which I call the intended state. And also I know that the runtime state of an application is going to differ from the intended state based on what the application is trying to do. So I also capture the runtime behavior. And what I do, one thing extra here is I take that runtime behavior and check with our backend system and look for the reputation feeds and make sure that what I'm saying as a part of the runtime behavior is compliance with what I'm seeing from my backend system, which are basically a reputation feed coming to us. And if there's any kind of deviation from that, we can basically alert it. So application visibility is a key portion of creating that intended state. And given its virtualization is a common fabric across data center, cloud, private or public, using that application visibility, we can basically capture a lot more information. The second thing I often get asked is like doing security. Like there are two ways you can do security, right? You can do security in hardware and you can do security in software. There are pros and cons of each approach. And the surprise here is that the pros and cons are exactly reversed when you talk about security in software versus security in hardware. When you try to do security in the software, the advantages you have of doing security in the software is you get this rich application user data context on which you can act on, right? So it gives you so much of context that you can basically base your security controls on. The disadvantage of doing security in the software is you are sitting in the same domain as an attacker. So when the attacker comes in, he's going to either shut down you, or since you're in the same domain as an attacker, you cannot trust your position when you do security in the software. If you do security in the hardware, as I mentioned, the advantages and disadvantages are exactly reverse. You're basically sitting in a separate domain as an attacker, so you can trust your position when you do security in the hardware. But you don't have any kind of application-rich context or user data context that you can feed in and align your security controls. With App Defense, what you have done is we have this Goldilocks zone. We always used to call it the hypervisor. So with App Defense, we are protecting or creating a protected zone for creating a secure enclave for the guest agent so that we control everything from the hypervisor. So when we do secure in the software at VMware, we are sitting in the hypervisor. So now the disadvantage we had where we are sitting in the same domain as an attacker goes away, because now we are sitting in a separate domain than an attacker. So we can trust our position and we can guarantee that this is something that we know of. So now we got advantage of both the world. We got the application context, which is very, very important when you want to align your security controls. And we also have the isolation of the networking piece because ESX taps into your networking top of rack switch. So we get best of both the worlds. And at the same time, we are not sitting in the same domain as an attacker, so we can trust our position. So isolation piece is a very big piece. And given that we are sitting in the hypervisor, we can do security in the software. And automation seems to be a buzzword everywhere, right? Because automation is key. And a lot of people don't take the approach of doing everything in software, or there was an article in Wall Street that software is eating the world. The reason a lot of enterprises are going towards a software-defined data center approach is they want to automate and orchestrate the entire infrastructure. So we started doing that with application using VRA, where you define your multi-machine blueprint and boom, you got a 3-tier application running in minutes rather than deploying it in hours. So automation is a fundamental key building block for SDDC adoption. What we're trying to do here with security is here that, as I mentioned, we want to create automated remediation for security response when we detect a threat. So automation is heart and center at VMware, and AppDefense goal is also to automate and orchestrate the response in the security theater when we detect a threat. And we have created a set of libraries for incident response based on ESX, NSX, and also we are working with our third-party ecosystem to integrate their responses as a part of that automation toolkit. So changing gears over here, I'm going to basically talk to you about what the architecture looks like. So as I mentioned earlier, AppDefense is a SaaS application. We got AppDefense Manager, which is running in cloud, and the whole heart and brain of AppDefense Manager of AppDefense is basically the AppDefense Manager, because it's a multi-tenant SaaS manager running in the cloud that basically provides each tenant view into their application intended state. You deploy an on-prem AppDefense appliance, which is acting as a proxy, and the only requirement for running AppDefense is you require vCenter. NSX and VRA are optional components, but they are very, very important. As I mentioned earlier, if you want to do a quarantine action as a part of remediation, you require NSX Manager. And if you're running VRA, we can tap into VRA to understand what blueprints you're trying to deploy for your multi-machine, and then we can capture that information to build the intended state of an application. But only requirement for us right now on day one is vCenter. NSX Manager and VRA are good to have, but not needed on day one if you don't have them. As a part of the components of AppDefense that you need to run on guest or your host is basically the webs for the host, which is basically storing the manifest of the virtual machine. So the installation of host webs is a completely non-disruptive process. You don't even need to bring the host in maintenance mode to deploy those webs today. And the guest agent is basically deployed per VM. And as of right now, the agent does require a reboot on a VM. And the rationale behind using an agent-based approach right now and not having that thing run in VMware tools is, as I mentioned, that we are running a SaaS-based model, so we reiterate very, very fast. And I've been with VMware almost like 2.5 years. And this is one product which I've seen is so simple and it's trying to reiterate so quickly. And I truly understand why enterprise and customers want to run in the cloud today, because they can reiterate very, very fast, right? So the goal here is that we want to start with an agent-based approach so that we can reiterate the agent very, very quickly and get those new functions and features that the customer asks for. At the same time, we are protecting that agent by creating an enclave or a shell around that agent by creating a protected zone in the hypervisor, which we monitor the agent to make sure that the agent is not compromised. So those are the two components that requires for AppDefense. So at the minimum, you basically require an appliance that registers with the vCenter, which is going to do all the crawl of a vCenter to get your VM and host level information, and all your process level information comes basically from your agent and the host webs that are installed as a part of AppDefense. One question I often get asked is like, you're having this thing run in the cloud, how secure I am, right? So the goal here is that we are not storing any customer data in the cloud. All we are storing is a metadata information that allows us to do this, ensuring good state of an application, and then we tap into the backend system, which are basically providing us the reputation feed for a process risk score that we need to know in order to basically create a threat alert. So the only thing we store in the cloud is your metadata. All the data that you're running is basically stored in your environment. And AppDefense appliance that is on-prem is just acting as a proxy to basically feed us that information. And as I mentioned earlier, right, getting that intended state engine is very, very crucial and very, very key element for us. A lot of security vendors have tried to solve that problem and have taken many, many approaches. And that's a very difficult problem to solve. So what we are trying to do here is, as I mentioned, to shrink and simplify the problem of security by creating the list privilege model for compute. So what we do is we tap into your vCenter and get information about all your VMs and hosts. And if you're not running anything else and just running your vCenter, we'll basically run AppDefense in a machine learning mode for 2 weeks so that we can understand everything that the application processes are trying to do. And that's how we build the intended state. We call it intended state or allowed behavior of an application, right? So that's the first state of creating the intended state engine for a particular application. And as I mentioned earlier, that every application goes through a lot of process chain during runtime. So runtime anomaly detection and control is part of AppDefense feature as well. So we'll monitor the real-time state of an operating system and user application. And we will basically also make sure that when we monitor that, whatever we see a deviation, we'll basically check with the backend reputation fed system to make sure whether that behavior is a valid behavior or that behavior is something that we need to act on in terms of alerting and control process, trying to modify or enumerate a memory location. We'll basically alert on that and basically detect an anomaly. We also got a built-in process analysis engine, which we call it a process risk score. So what it basically does is it basically provides you the overall process risk score in terms of specific traits that are potentially suspicious. So we checked with the backend reputation fed system, we take your process, check against it, and if we find that based on the analysis engine, there's some kind of malicious behavior we are seeing with that process, based on the specific thread, we'll basically alert that process risk score to a high value so that you can take an action on it. And the key thing here is once you do that intended state right, we can basically orchestrate and automate the remediation phase of security where we can use ESX, NSX, and third-party ecosystem tools that we can remediate as a part of security response to a particular threat event. The key part of doing security in the software and doing an agent-based approach here is that we basically, as I mentioned earlier, we create a protected zone. We call it a virtual enclave within an hypervisor that provides a shield to the security agent. Because once you start doing security in the software, you need to ensure that the agent that is running in your virtual machine is protected. So the way we do it is we create a protected zone in the hypervisor, and we basically do a full code and data protection of that particular guest agent in the kernel. And we are also monitoring, there's a VM monitor that is part of vSphere 6.5 that monitors the guest agent and compares it, does a reconciliation with what is stored in the hypervisor from the VM manifest standpoint. And if there's any deviation, we know that the agent is getting compromised and we can start acting on it. So we do monitor all the drivers, all the code pages that are inserted by the operating system prior to the module getting started. So once we have that state, we actually do a reconciliation and monitoring between our hypervisor protected zone to the guest agent that is running in the virtual machine. And as I mentioned earlier, we do have a monitoring system running in the kernel that basically monitors every module, which is basically the load and the unload request in the guest. And we also have verified signatures of the loaded modules that we compare and contrast again. Because at the end of the day, if you look at the process, it has got a path on it. It has got a hash value on it. So we basically compare those values and the path to make sure that if that process is getting enumerated, the monitoring system can basically take care of it and detect it in a very early phase. And one key important thing is we always talk about this like doing in-memory scanning. The main issue of not doing in-memory scanning is that the CPU gets spiked up to like 30–35%. And that is the reason that in-memory scanning is always a costly operation for the compute layer. So what we do in terms of in-memory scanning here is, if we detect that the process is deviated from a known state to a state that is kind of an anomaly behavior, and if we understand based on the process risk score that this is a very high risk score for that process, once we have done all the detection, then we'll go and do an in-memory scan for that particular process to make sure that what memory locations and others are getting modified. We only tap into in-memory scan process once we detect that there's a high-risk event that is happening that we need to prevent. We don't do in-memory scan for each and everything that we see out as a part of deviation from the intended state behavior. And the third and the most important thing is monitoring the memory and the process. So we basically monitor the guest pages and the mappings to basically ensure that we have a consistent view both from inside and outside of the guest agent by copying a shadow copy of the guest process table into the hypervisor. And this is what I call the reconciliation between the hypervisor protected zone security enclave of the VM to the guest agent. And this is very, very important when you're trying to do an agent-based approach in security, so that you can trust your position and at the same time, you can provide a shield around your agent. Now, going back to what is required in order for you to consume AppDefense, right? So the only requirement I mentioned earlier is we require vCenter, and the minimum version of vCenter we require here is vCenter 6.5, and it works with ESXi 6.5a. And I know that it's a lengthy process. A lot of our customers are just getting to 6.0. The reason we have 6.5 as a minimum support for AppDefense is because 6.5a basically introduces a lot of security features in the kernel, and it also has the VMM and the VMX monitoring module in 6.5a, which we use extensively to provide the host and the guest integrity of the modules that are loaded as a part of AppDefense. So if you are running 6.0 and having issues getting to 6.5, definitely contact us and we can basically give you some of the information we have got from our customers in terms of what we are doing with getting our customers to 6.5. There's a project substrate at VMware as well that can help you to get there. When we opened the curtain on AppDefense at VMworld 2017, 2 weeks ago now, the guest operating system that we just came out for support is Windows 2012 R2 and Windows 2016. We are looking at Windows 2008 R2. We are also planning to get the CentOS Linux support for the guest agent out next month. This is all running in cloud, so we reiterate very, very quickly. So the support for CentOS Linux is going to be available next month, October 27. And we also have customer asking for support for Red Hat Linux and so on. So all those guest agents are getting rolled out quickly. And we also had a lot of questions asked around getting a guest agent for physical workload containers and what may have you. So that is all scheduled to come out by next year. And as far as integration is concerned, we integrate right now with VMware NSX 6.3 if you want to do an automation with a quarantine action. And we also integrate with vRealize Automation 7.3 so that we can ingest all your multi-machine blueprint into AppDefense as a part of building that intended state engine. Let me define the installation process. So once you confirm that you have met the prerequisite, this is one of the most simple products I've found in VMware as a part of installation and getting it up and running. I had this installed in my lab like 3 weeks ago, and it literally took me, I would say, around 30 to 45 minutes. The first thing we'll do is we'll provision an AppDefense account for you, which is done by VMware, which is basically getting an account in the VMware AppDefense Manager. And then what we do is, from there you go and get all the code for your appliance, for on-prem, or host scripts and what may have you. And we give you the UID and the API key for your appliance, which is what you put in order for connecting your appliance to the AppDefense Manager. So once you get that UID and app key, you basically go on your prem and deploy the OVF file, which is your AppDefense appliance. Once you deploy your AppDefense appliance, you configure it with the UID, API key, and vCenter. That basically connects your on-prem AppDefense appliance to your AppDefense Manager in the cloud. If you're running your VRA and NSX, you can do all that integration as well. Once you're configured and got that connectivity working between your AppDefense Manager and your AppDefense appliance on-prem, you basically deploy your host module, you enable your guest integrity, and the last thing you do is deploy your guest module, and off you go. You got your AppDefense infrastructure up and running. From the ecosystem partner, I'm not going to go through each of them, but we already have the code right now that is running that is integrated with Puppet and SecureWorks. We also announced at VMworld that we are integrated with Carbon Black, RSA, and IBM Security, and each one of them have their own separate space in the world of security theater. So we basically provide them the application intended state, good behavior that they can tap into to make their solution much better and reduce the amount of false positive. This is my favorite slide because it's something I really liked when I saw it. And this is basically the quarantine action that I was talking about with AppDefense integration with NSX. So what happens here is, if I define an action, which I'm going to show in the demo, which is a quarantine action, when the threat is detected and the action is set to quarantine, AppDefense basically goes and tags that machine with a tag called appd. And then it basically calls NSX APIs that does three things. It creates a security group, a security policy, and basically puts that VM, any VM that has got a tag called appd, becomes part of that security group called AppDefense. And then basically the policy is to block all inbound and outbound connection, because you want to stop the propagation and extraction of the data. So once you block all that connection, nobody's going to go out. These are all the links that are available for public consumption. I would definitely recommend the AppDefense technical blog that was written by all of us, which basically goes into detail on all the learnings we had from our customer. Folks who were not able to make it to VMworld 2017, Tom Kahn is a senior VP at VMware, and this is his baby. He's been working on this for 2 years. So I would highly recommend to watch the 52-minute video that was done by Tom Kahn at VMworld. Let's get into the demo. Ariel.
Go for it.
So I got around 6 minutes left. So let me just quickly go through the
Don't worry about the time.
Demo part of it. So what I'm doing here is I'm logging into that SaaS portal, which is basically my AppDefense manager. So once I go to that AppDefense manager, as I mentioned, we'll create an account for you over there. And this is running in the cloud, managed and maintained by VMware. So once I come into this portal, right, let me walk you through a step-by-step approach. And the theme today is going to show you a demo that we did at the Hack New York City conference which was a forum of OWASP. So what I do here is I go into my AppDefense manager, and this is where I'll get all my WIPs for the host. I just click on this WIP and I get the WIP for the host that sits on the host machine. The next thing I'll do is I'll get my guest module, which will be part of my virtual machine. And again, this can be baked in your golden image as well as a part of the virtual machine bringing up. And the third thing I'll do is I'll basically go and get this OVA file, which is a file for deploying AppDefense appliance on site, which taps into your vCenter. I also got all my documentation over here. So that's all the software that you'll download from here. And as I mentioned, when you provision a new appliance, you basically get a UID and an API key that you need to store and provide to your AppDefense appliance that is running on site. So here I click on provision new appliance, and it's like a 3-step process that basically you give a name for an appliance, you tap into, you get the UID and the key information, and then you just hit the copy button to store that information, which you can use when you bring up AppDefense appliance on site. In my case, I got an appliance running, which is called OWASP, which is on site. And as I mentioned, I'm going to first crawl your vCenter and get everything about the entire lay of the land of your data center. So what I'm showing here is that when I tapped into your vCenter, I get all the information about all the hosts that are running on there. And if you see here, I've basically taken a couple of hosts and I've installed the host WIPs on it for AppDefense. So it shows me that these machines are ready for running AppDefense on it. Again, the installation is done for host. I highly recommend you to install it for cluster, because if the application is getting vMotion, then you want to make sure that that application has got AppDefense feature when it goes across multiple hosts. And the second thing I learned about tapping into vCenter is all your virtual machine. So as I mentioned here, this is supported right now with Windows. So if I see here a machine called Coke Linux, I'll show you that this is not a supported module for it, and it's not an unsupported version of Linux that I don't support today with my AppDefense, right? Anything that is supported will show up like here. So this is my application which I'm trying to tap into. So this is my Windows critical database system with a VM ID, and I basically enable guest integrity and install AppDefense 1.0 guest agent on this virtual machine. The other requirement which I did not cover is we require VMware tools 13 or better. We are not using it today, but our end goal is to basically get rid of guest agent and make it part of VMware tools. So we recommend from day one to run VMware tools 13 and better. And if your guest agent is installed properly, you should see this guest module status as active, which means that now you've got the AppDefense infrastructure up and ready to start working on your data center. And in the world of security, one thing I always get asked by a lot of CISO and a lot of security practitioners is, we need to keep track of all the events that are happening in data center, because that is basically the signature of data center, who is coming, who is going, what time they are coming in, what intent are they coming in, and what are they trying to do. So we do store all the provisioning events that happen in the data center as a part of AppDefense as well. Now just focusing on this demo that I'm going to do here, what I've done here is I have two VMs that I selected as a part of the application scope. So I can do add service. I can define the service name. I'll just call vBrownBag demo. And here is a list of things I can pick from, whether it's a web server, app server, database server, what may have you, right? And you can customize and create your own. So I can call it FHS server. Then I do next. And then it gives me the list of VMs that I can pick from in order to create the scope of this application. I already created one, so I'm not going to pick anything here. And then I just run it in a learning mode for 2 weeks, which is what I've done here. But the only thing I'm running in my demo is vCenter. I don't even have NSX running. So the only components for my lab is vCenter, 6.5, vSphere 6.5a, and AppDefense 1.0. And I got 3 virtual machines running, out of which 2 are part of application defense, and the third one is just running, which is completely patch machine. So what I did at the Hacker New York conference is I took one Windows web machine that is talking to the database, and the web machine is basically completely unpatched, and I'm running AppDefense on it. So that web machine has got all the vulnerabilities that you can think of available on it. And what I was trying to do is use the Equifax kind of hacking, where I used the Eternal Blue exploit, and then using that exploit, I was doing reverse TCP connection into my web server, and using some password hacking scheme, I just got in the server and trying extracting it. And I'll show you how the AppDefense actually blocked that attack when it came to propagation and extraction. So the first thing is, when you're running this in a learning mode, it does all the machine learning. And here it is saying that based on all the learning, I found the 6 processes that are running on that application. If I click on one of the processes, it says this particular process is running from this particular path, C:\Windows system32 SVChost.exe is the name of the file. The hash value for this particular process is going to be E4, whatever that is, right? And then when I click on the further information on that particular process, I basically see all the connections this process is trying to make. So I can tell that port 53 is basically my DNS service. So I can tell this is 96.47. If I know this is my good address for my port 53, I can validate right here. It also shows me all the inbound connections that are coming into this particular application. So it tells me that there's a UDP connection coming on port 5335, which is coming from the database, because I'm using Postgres, and that uses port 45355. So again, the goal here is I'm creating an application birth certificate based on my learning, so that I can start doing intent-based security, right? And as I tell, application is never going to be deviating again from the intended behavior. There's always going to be a runtime behavior. So in this particular case, I've got Google Update, which is running periodically and trying to update Google applications. So as you see here, right now what I'm seeing is there's a TCP outbound connection going to Google on port 443, and this is a hash value. So we take all this information and we basically do checks and balances with the reputation feed that we are getting from the OEM system in the backend. And we validate all your path, all your hashes, all your inbound, outbound connection. And once we know that this is a good state, then that is what we lock it, and we call the intended state of an application. And anything that deviates from this intended state, you can do a lot of fancy things, right? And that's the next step what I'm trying to show you. So in this particular case, what I can do here is, this is all my allowed behaviors from what I have seen for this particular application. And if a particular application developer says, I have a particular behavior that I want to add to this behavior, you can also add a customized behavior if you want to. So I just click on the add button, and it allows me to add a behavior that I know is a good known behavior. So I can pick up anything I want to, right? So this is basically my allowed behavior, and it tells me what ports and protocols I'm opening for what ports over here. And the rules is an important thing, right? So there are 4 things we try to do. The first thing we want to make sure, because we are running in an agent mode and we are trying to create a security enclave for that agent, we basically want to enforce the guest operating system integrity as well as the host module integrity. So if anybody is trying to hack the host module, which is a protected zone or a security enclave for the guest agent, we want to take an action, right? So the actions are based on VMware vCenter or NSX today, right? So you can always do a couple of things which we'll talk through in detail. And the 2 other things that we do as a part of the rules is enforce inbound and outbound connection. Because if you look at the attack chain, right, infiltration is where a lot of money is spent, but the attackers still come in, right? The next phase of an attack chain is the propagation and the extraction phase. That is where we are trying to focus AppDefense on. So if we can block the propagation and stop the extraction of the data, we are basically now trapped the attacker. So that is where this enforced connectivity comes into play, because that is where the attackers get trapped and not able to open reverse TCP session, because you're going to block that outbound connections to it. So the things we do here is using the set of libraries from vCenter. We can either snapshot a VM when we found deviation from the intended state. We can suspend it. We can power it off. We can just simply send an alert to the SOC operator saying that there's something that is deviating from what I know is a good known behavior of an application, right? I can also block that behavior and send an alert. So I'm taking an automation action here and also sending an alert. And the quarantine is one action where I can basically integrate with NSX and just make that machine part of a AppDefense security group and block all the inbound and outbound connections to it. So let me go and just show the alarms. I know I'm going a little bit above the time here, but as a part of the demo, what we did was we used the Eternal Blue exploit and did a reverse TCP connection into this application server and trying to log in password with a known good password that we knew of based on hacking system. And once we try to come in, we are not able to do any session using reverse TCP because we are seeing this outbound connection rule alert or rule violation happening in our AppDefense. So if you look at this rule violation, what I'm trying to show here is that somebody is trying to access this machine from outside. And you see here the local address is 000. The remote address is basically my broadcast domain. And this is what it's trying to access, svchost.exe, which is a file required for doing a reverse TCP connection. And this is very important. So as I mentioned earlier, we tap into the reputation feeds to basically take the process and try to see what the risk score of that process is. So based on looking at this process and the behavior that we are seeing, we see that this process is risk at a medium score. And these are the 45 drivers or the modules that this process is trying to access. And if you see here, there's a crypt DLL, which is basically used by WannaCry to crypt the files on it. So it is basically going to crypt it, then it's going to go a kernel call, which is a silent call. Then it makes a DNS API call to basically call my DNS server to manipulate the entry for my remote host, gives me the attacker DSCP address, and that's how I get my data out. So it actually gives you the entire signature of what is happening at the process level, at the operating system kernel level, and what the attacker is trying to do. So not only you trap this attacker, but you exactly know what that attacker program is trying to do once it comes in your data center. And this is very, very important because once you have this signature, you can start honeycombing this attacker and trap him really, really bad so that you can not only keep him out, but you can get them really, really frustrated, pretty smart. And this is the remediation status which I talked about, which I said block this attacker. So it's going to block all the connections that the attacker is trying to make. And also at the same time, I'm going to send an alert to the SOC saying that something critical is going on. Already taken an action, which is a remediation action automatically, but for you to go and actually look at it and see what's all is going on. So again, the goal here is to automate and orchestrate every single thing we can in the world of security. So just to summarize everything I talked about, it's a very, very powerful tool. It's a very tough problem that we are trying to solve at VMware using a totally opposite approach of ensuring good versus chasing bad. And just to give you a little premise, one thing if you want to remember from this vBrownBag is remember this number called 27 million and 91. So last I checked a week ago, there were 27 million known threats that were documented in a global threat database. And that is what all the antivirus, anti-malware vendors go and compare anytime they see a deviation or a threat. And they try to protect you against it, and that process is still broken, right? Versus we have 91 good behaviors that we are documented by running AppDefense over the course of 4 months in our environment. And we can say if we protect these 91 good behaviors, we are basically protected from those 27 million threats. So that is the reason I say we are trying to simplify and shrink the problem of security. And the best thing this comes to my mind here is I was in India when US launched their first satellite and they had the person going in the moon. And one of the problems they're trying to solve is like, how do we come up with the ink for the pen so that they can document everything when they go to the moon, right? And at the same time, when Russia was trying to put the satellite in the space, they said, forget about figuring out the ink and everything. They just give a pencil to that guy to go up, and pencil works all the time in space. So again, they simplified that whole problem. Rather than reinventing the new ink and the new pen, use the existing tools that you have in place, which is a pencil that can go in space. Same thing we are trying to do is, rather than reinventing the problem and trying to secure the way it has been doing, just shrink and simplify it, because there's a lot of information you already have. And again, virtualization is a common fabric across data center, cloud, what may have you. And if you're doing everything in software or SDDC, AppDefense is a perfect candidate for you because it gives you application visibility, it gives you that isolation from the attacker domain, and it gives you that automation and orchestration piece in the world of remediation for security. So again, let's start ensuring good rather than chasing the bad in the world of security. Thank you so much, Ariel, and happy to work with you all if you have any questions on this.
All right.
So again, thank you so much to Bhavin. And please reach out to him on Twitter if you have any questions, or reach out to me, Brian. We'll make sure that we get you and him connected. Thank you.